All right, so question 2J says to factor completely. So to factor completely means to factor twice. So to factor twice, you got to know all the techniques. So the first technique we learned was GCF. Second technique we learned was dots. That's the bell. There'll be one more. And number 3 was trinomial. Okay. So when you factor completely, which technique do you always try and deploy first? GCF, dots, or trinomial? Always GCF. So the GCF is what's the most they all have in common? What's the biggest number that divides into 2, 16, and 18? And remember, the GCF can't be any bigger than your smaller of your numbers. So if I'm looking at 2, 16, and 18, my GCF couldn't be any bigger than 2. Because if 4 went into 16 and 4 doesn't go into 18, but if it did, 4 couldn't possibly work because it doesn't go into 2. So my GCF is going to be as big as my smallest number, which is 2. So my GCF is going to be 2. So I'm going to write over here, GCF, kind of sloppy, like I like to do, 2. Do these have a letter in common? Do they all have a letter in common? There's a second one. No, they don't. He's got x squared. He's got an x. He doesn't have any x. So I cannot take out an x as well. If they had an x or 2 in common or 3, I would take out 2 or 3. But they don't have an x in common. So what I'm going to do is you write your GCF. You put it in front of an open set of parentheses. And remember, we divide all of these by a factor of 2, whatever your GCF was. Okay? So 2x squared divided by 2 becomes invisible 1x squared. Plus 16 divided by 2 becomes 8 with the last name of x. And then negative 18 divided by 2 will become negative 9. Okay? And I'll even make that 2 red in front because that's our GCF 2. So right now we factored it once. Okay? We have to factor it twice. So now that we've done the GCF, he's gone. Shouldn't have to GCF again if you took out the GCF correctly. Looking at the blob in the parentheses, am I going to wrap this up with a dots factoring or trinomial factoring? Does this have 3 pieces or 2 pieces? This is 3 pieces, 3 terms, trinomial, boom, boom, boom. So when we factor using trinomial, remember, we bring down our 2 and we draw 1, 2, 3, 4. What goes in the first spot of each one? X and X. Okay, and then we play the riddle. AM, remember that game? 2 numbers that multiply to give me negative 9, but add to give me 8. Now, there's not too many numbers that multiply to give you 9. It's either going to be 3 and 3 or 9 and 1. We got to add to 8. There's no way we're adding to 8 with 3 and 3. So it's got to be 9 and 1, and the signs are going to matter. So it doesn't matter which one you put the 9 and the 1 on because you're going to have stuff with the signs in. So I'll put the 9 here, 1 here. I need them to multiply to negative 9, so I know only one of these is negative. But they add to positive 8. So that means I know that it must be true that the 9 is positive and the 1 is the negative. Because if they add to positive 8, the bigger of my 2 numbers would have to be positive. The sign of your middle sign will match the larger sign's number, or the larger number sign. There we go. Okay? This is factored completely. I factored twice. Done. The other trick to knowing that you're done factoring is there's no exponents. So if the exponents are all gone and everybody's a nice linear term like this is, I'm very confident that I factored this completely. Okay? That's it.